Welcome to this class. In this session, we are going to prove these four derivatives of trigonometric functions, that when you are given y is tan x, then dy dx is sec squared x. If the function is y equals to cot x, then dy dx is negative cosec squared x. If the function is y equals to sec x, dy dx is sec x tan x. And if y is cosec x, then dy dx is negative cosec x cot x. So let's quickly see how we prove this. So proof of the first one, y is tan x. So recall that tan x is the same as sin x over cos x. This by definition. But tan can be written as sine over cos. So we use quotient rule. i.e., let u to be sin x and let v be cos x. Now when u is sin x, then u prime, derivative of sine function is cos function. Derivative of cos function is v prime negative sine x. This is u prime, this v prime. So then, by definition, dy dx is given by u prime v minus v prime u divided by v squared, which will be given by, now u prime is cosine of x, v is cos of x, minus v prime is minus sine x, and u is sine x, divided by v squared is sine, v is same as cos, so the cos squared. Cos x squared. So dy dx is given by cos times cos is cos squared x minus minus is plus, so sine squared x over cos squared x. But we know that cos squared x plus sine squared x is 1. Then this implies that this derivative will simplify to dy dx equals to 1 over cos squared x. But 1 over cos x is the same as sec x. So it's the same thing as saying 1 over cos squared x is the same as sec squared x. So therefore, dy dx equals to 1 over cos squared x is equals to sec squared x. Hence, when y equals to tan x, then dy dx is sec squared x. So that's the proof of the first one. The second, y is given by cot x. Now from definition, cot is cos over sine. So cot x is the same as cos x over sine x. Remember, cot x is the same as 1 over tan x. So simply the reciprocal of tan is cot. So let u to be cos x and let v be sine x. So that u prime will be negative sine x and v prime will be cos x. Now by quotient of dy dx is u prime v minus v prime u divided by v squared, which is u prime is minus sine x times v is sine x minus v prime is cos x, u is cos x, and then v is sine x, and then we square. So this means dy dx, this will be negative sine squared x minus cos squared x divided by sine squared x. But because this term and this term have negative sign, then we can factor out negative and say sine squared x plus cos squared x divided by sine squared x. But sine squared x plus cos squared x is 1. So this implies dy dx will be negative 1, because this part will be 1 over sine squared x. And we know that one over sine x is the same as cosec x. So when you say 1 over sine squared x must be same as cosec squared x. You're just squaring both sides. Therefore, dy dx equals to negative cosec squared x. Therefore, hence, given y equals to cot x, then dy dx is negative cosec squared x. C, y is given by sec x. So by definition, sec is the same as 1 over cos. So solution, y equals to sec x is the same as 1 over cos x. So we let u to be 1 and v to be cos x. So this implies u prime is 0, v prime is negative sine x. Now dy dx is given by u prime v minus v prime u over v squared, which will be 0 times cos of x minus v prime is minus sin x, and then u is 1, and then v is cos x, and then we square. So I'll have dy dx equals to 0 times cos x is 0, minus minus is plus. So I'll have sin x, and then this cos x squared is the same as cos x times another cos x. And you see this can be written as 1 over cos x times sine of x over cos of x. It's still the same expression. And the definition of this part, 1 over cos is sec, and sine over cos is tan. So therefore, dy dx is sec x times tan x. So hence, given y is sec x, then dy dx must be sec x times tan x. The last proof, now y at d, y is given by cosec x. So by definition, y equals to cosec x is 1 over sine x. So let u to be 1 and v to be sine x. So this tells you that u prime is 0 and v prime is cos x. Now dy dx is u prime v minus v prime u divided by v squared. So replacing the values, so u prime we put 0 times v is sine of x minus v prime is cos x times u is 1 over v squared is sine of x squared. Now dy dx, 0 times sine x is 0, so this will be negative cos of x divided by, so this can be written as sine x times another sine x, so it's a product of 2. And this can be written as negative 1 over sine x times cosine of x times sine of x. So that's how we can write that. And you see, in this new expression, this is the definition of cosec x, and this is the definition of cot x. Oh, there's a negative sign. So i.e. dy dx will be negative cosec x cot x. So therefore, in general, hence, given y equals to cosec x, then dy dx is negative cosec x cot x. So that's how we prove those trigonometric derivatives. Thank you.